One of the most important areas in number systems is factors. Every year you will find questions related to factors in many of the MBA entrance examinations, one of them obviously being CAT. Now, I have written down 5 questions which are the most common questions related to factors. If these 5 are clear, I believe many of the other questions can also be solved very easily if they are related to factors. Now, the questions are total number of factors, a total number of odd factors, total number of even factors, total number of perfect square factors, and total number of perfect cube factors for any given number. How do we find it? Now let us take a number which is n is equal to 2 to the power 4 into 3 to the power 5. I have got this after I did something called prime factorization. Prime factorization is nothing but a way of breaking down a number in terms of its prime factors. So after doing the prime factorization, I have come across that number as 2 to the power 4 and 3 to the power 5. Why do we call it a prime factorization? Because we represent the number in terms of the prime factors or prime numbers that constitute the original number. As you can see, it is 2 to the power 4 into 3 to the power 5. Now before I talk about the actual method of finding the factors, let us take a smaller example, because that will help you to understand better. For example, let us take a number 6. What are the factors of 6? The factors of 6 are 1, 2, 3 and 6. Now how did we get this 1, 2, 3 and 6? What are the ways? Now they said that every factor of that number is actually a combination of the different prime numbers that constitute the original number. Now what does that mean? Okay, now let us see. When I break it in terms of the prime factors, I can see that 6 can be written as 2 to the power 1 and 3 to the power 1. Or we can say there is 1, 2 to the power 1, and there is 1, 3 to the power 1. Now let us try and look at this. These 1, 2, 3 and 6 are nothing but a combination of a 2 and a 3's power. Now what does it mean? Like 1 is nothing but 2 to the power 0 into 3 to the power 0. 2 is nothing but 2 to the power 1 into 3 to the power 0. 3 is nothing but 2 to the power 0 into 3 to the power 1. And 6 is nothing but 2 to the power 1 into 3 to the power 1. As you can see, I can write every single factor of 6 in terms of different powers of 2 and 3. But there is something which is different out here. What? If I look at 6, I see that 2 to the power 1 and 3 to the power 1, which makes 6. There is only 1, 2 and 1, 3. But here we can see that along with 2 to the power 1, I have got a 2 to the power 0 also. And along with 3 to the power 1, I have got a 3 to the power 0 also present in these factors. Now, what do I mean by that? By that I mean, we all know that 1 is a factor of all numbers. So how do you represent 1? 1 is represented by the 0th power of all the prime numbers that make this original number. So basically when I say that I have got 2 to the power 1, that means I have got a 2 to the power 0 and I have got a 2 to the power 1. If I say that I have got 4 different powers of 2 out here, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, I will be wrong, because there are actually 5 different powers of 2. 2 to the power 0, 1, 2, 3 and 4. Similarly for this one, I can see that there are 5 different powers of 3. 3, 1, 3, 2, 3, 3, 3, 4 and 3 to the power 5. But actually there are 6, because we need to consider 3 to the power 0 as one of the powers. Because if we do not consider 3 to the power 0, then 1 cannot become a factor of this number. So what happens if I again come back to this number? So I have got 2 different powers of 2 and 2 different powers of 3. In how many ways can I combine them? I can combine them in 2 and 2. That is 2 and 2, 4 ways. So the total number of ways is 2 into 2, which is 4. 4 is the total number of factors of 6. Now let us try and apply the same thing in that previous question. So how many different powers of 2 I have? I have got 5. And how many? For 3 I have got 6. For every single power of 2 I can make 6 different combinations. So in all, how many combinations can I make? For this one 6, this one 6, this one 6, this one 6 and this one 6. So there will be altogether 5 into 6, which is 30 factors are there for this number. Now they have given us a rule to follow, which I don't. If our number n is represented as p to the power a into q to the power b, then the total number of factors is always given as a plus 1 into p plus 1. Where from do we get this one? These ones are nothing but the 2 to the power zeros or the 3 to the power zeros or the 5 to the power zeros that are present in that number. Clear? So we get a total number of factors by this method, where we have to include